So today the DS Incubator continues with the series about working with Git from the terminal. Today is an exciting lesson because we are going to be talking about sharing repositories online and using this idea of remotes, which are repositories that live in a computer outside our own computer. Or sometimes actually it could be a remote inside our own computer too. So basically the idea of remote is relative to one repository that is conceived as local. So I've been skimming through the lessons about remotes, and the information is kind of scattered. So I'm gonna give you first an overview about where you could find information on your own, and I'm gonna really kind of cherry pick the few things that I think are key and show an example. So the lesson that you're looking here on screen is a very quick introduction to setting up a remote repository, which we are going to cover. But it doesn't have a lot of wisdom, really. Instead, when you go down that lesson, you will see that there is a section that talks about cloning a repository, and it has a link to a whole new lesson about collaboration with distributed version control, which is Git. So when you click there, then you will find a bunch of other lessons that you're welcome to explore. I don't think we're going to cover all these lessons because we will be moving really too slow. And I think that at this stage, a lot of us have a lot of experience with Git, and I think we just need to spend some time kind of clarifying the few things that don't seem to work quite well all the time. So I would prefer to spend more time in just polishing the few things that might be unclear, as opposed to just going through a huge overview of things that are a little maybe already kind of understood. So instead then, so this time kind of departing from the lesson quite a bit. So instead the motivation is going to be working with one particular repository, like a real life case. I'm here in a repository that lives in the 2 Degrees Investing organization. The repository is called R2AI Match. It is an R package, but it is just, in this context, it is just GitHub, a Git repository that is hosted remotely on GitHub. So in covering more or less the topics of the first lesson, the very first thing I wanted to talk is about how you set up a remote. So today I'm going to be working from my own terminal because I feel more comfortable there, and it kind of more closely shows how I actually do things. And with this, I'm hoping to kind of inspire you to find your own tools that work well for you. And doing so is important because it can save you a lot of time and headaches. And I'm going to be trying to advocate for the idea of using tools that automate processes that otherwise could be very easy to make mistakes. So how we configure a clone, and again, I'm going to be talking about this example working with this particular repository. So, okay, so I have this repository online, and one of the many ways in which you create a connection between a remote repository, a repository that lives in this case on GitHub, and a local repository is by cloning it. So that's a quite common workflow. Other ways could be when you create a repository from scratch, but that is not so common. So the lesson actually was showing quite a bit on that. And I'm gonna basically skip it because it doesn't have a lot of new things to us here. So what I'm gonna do is I'm gonna open a terminal here. I'm gonna make this a little bigger. There we go. Let me close something else that is bothering me here. So I am here on my local computer on a repository called TMP for temp, and here I'm going to execute the command Git Clone, which basically gets a repository that is somewhere else into the location where I'm standing right now. So in this case, inside this folder called TMP. And you have to give it, in the same way when you visit a web page, you need to visit, a URL, right? Something that starts with like HTTPS, whatever. This is very similar. This is also a URL, but it might look a little different to what you are used to. And the reason is because Git has more than one kind of URL. So when you click here on the main page of a repository, just by clicking the name on it, for example, if you go to code, you will see that there is this address here. That is the URL that I used to connect basically my GitHub repository with my local repository. If I click on the HTTPS tab, this URL will transform in something that is more common for those who use HTTPS. If you don't know the differences between HTTPS and SSH, it's fine for the purposes of this lesson, but everyone in this meeting is very involved in Git and GitHub, so I recommend investigating on your own time what it is an SSH connection. Basically add some security to the way you communicate to GitHub. So you could copy that address in however you like and then type it on your terminal. And that should just do the trick. So I'm gonna execute that command and see what happens. As you can see, Git is already cloning that repository. We can think of it as an action of downloading the repository. Remember that a Git repository is just that one .git folder that contains not only the state of the project as it is now, but also the entire history of changes of that repository. So I had just cloned this repository from this address. How to interpret this address in the HTTPS protocol might be a little easier. So I'm going to explain this one here because it's a bit less natural. Basically, as you can see here, you recognize the owner account, in this case, the organization 2 Degrees Investing. If you are cloning something from your own account, you could have your user name there. And then here is the name of the repository, ends in Git. And basically, this is a connection between a remote, computer here and you. So the first thing I need to do now, because I cloned the repository, and if I do an ls, I should see that listed in the inside this directory. I should see somewhere this repository here. So the folder has been cloned inside my working directory. So I'm gonna cd change directory inside r2dir match. And the command to ask Git about remotes is git remote. So you do git remote. And if I do just that, I will get a name, which is a nickname for the remote, but that is not very informative. Instead, you would usually want Git Remote Minus V. V stands for verbose. So let's see what happens if I do just minus V. Maybe, I think I get the same information. So basically Git Remote Minus V will tell me what is the connection that I have available between my local repository and the repository I have just cloned. And as you can see, this is the address that I typed. And origin is just a nickname, a way that I can use to refer to that address without spelling it out, because it's awkward, it's long, it's easy to forget what it is. So I can refer to that remote just by using the word origin. There's nothing special about that name, it's just a default name for, between Git and GitHub. That's the default that you get. So my connection is there. I could do something like fetching the latest changes. So I have cloned this repository a few moments ago, maybe 2 minutes ago while I was talking. So what if someone included a new change into this repository on the remote? Well, this is one of the very first things that I really want to kind of emphasize and make sure we are on the same page. This idea of keeping in sync your local repository with your upstream repository, in this case, the repository in the 2 Degrees organization. It is crucial because if you're gonna start working now on a pull request on a branch locally that then you intend to submit to the remote repository, then you want your local branch to be as updated as possible compared to the remote one, right? So the very first things you could do is to bring all the metadata associated to this repository from the remote. So I could do something like git fetch. And you could be explicit and say, what do you want to fetch? I want to fetch from the address origin. And this is not important here because I only have one connection, but I could have many connections. I could have many remotes in many different places. For example, one remote could be pointing to 2 Degrees Investing Organization. Another remote could be pointing to my own user account. To that one, sometimes we call it a fork. And then you could keep many remotes, many addresses, and each of them could have a nickname. It is quite common that if you have only one, then that one would be your origin. And when you fork something, generally your origin becomes your own fork. And the one that is the main source of truth, the one of the organization, is generally called upstream. I'm just throwing a lot of jargon here. I'm assuming that a lot of us heard that jargon before. It's not going to be something new, but please do ask me if it's unclear. So for now, I'm going to just use a very simple example where I'm going to use this remote to do something. So I have just fetched the changes from origin, but I haven't actually merged anything. So if there was a change, which there wasn't because Git didn't give me any information about changes, but if there was anything, I couldn't have included those changes into my master branch. To do that, I could have needed to do something like git merge origin master. What does this mean? Well, you already know what a git merge is because we have been talking about branches and how to merge branches. And you know that if you are standing on one branch, in this case master, and you say git merge some other branch, then those two branches get merged. In this case, the syntax may look a little weird, but this is just the branch. So you can refer to a branch by giving it the name of the remote / the name of the branch, right? So if I do that command, I'm saying, hey Git, please merge my master branch here with the master branch, but on origin. And I could do weird things like merging the master branch locally with a branch that is not called master. It could be called whatever, right? So you have the freedom to merge whatever you want. But that's the syntax: git merge remote / branch name, basically. So that is pretty common, to fetch something and then merge those changes. Merge is the actual way of changing your local repository, but fetch does not change your local repository. It just gets the metadata so that you can then execute merge. But because those two actions are so commonly followed, merge follows fetch, there is a shortcut, which is git pull. So if you do git pull, if you do nothing else, Git will try to use any setup configuration that it already has. So I'm gonna just run git pull and see what happens. It looks like that Git already knew where to get things from, and the reason is because there is automatic things that Git does for us when we clone a repository from GitHub. I'm gonna show you that in a moment to just know exactly which branch from my local computer is tracking which other branch on the remote. But for now, what I wanted to express is that git pull is a shortcut for git fetch and git merge. It is the exact same thing. If I do git fetch origin and then git merge origin master, I achieve the same that I achieve if I do just git pull origin master, right? So let's try that in a more explicit way. Actually, I don't think the pull may have it. Origin. I don't think this will work. Let's see. Master. Yeah, origin master. That's not the way you execute the command. So just git pull origin. That would be the way you express it. So one way, how do you know that which branch Git will associate on the remote to your local branch? Well, remember the command git branch. If you say nothing else than git branch, you get a very boring description of your branch. But if you do git branch minus VV, you get a more informative one. So how you read this, sorry for the colors, my screen is probably a bit too light. What this means is that the local master branch is automatically tracking changes on the origin master branch. So that means that when I do git pull, the branch that Git will pull from the remote is the one that is configured here, right? And let me show you what the world looks like when that automatic upstream is not connected. So let's say that we want to create a pull request. So the first thing that we do is we create a new branch. And actually, the way I generally do it is git checkout. Oops, sorry, I didn't mean to do that. Git checkout minus V, which creates a new branch and then checks it out, and let's call it PR. So I have effectively created a branch and have moved to that branch, but if I do a git log, say one line graph, one line decorate, as you can see, both my master branch and my PR branch are still pointing to the exact same commit because I haven't done any change. So let's start doing something here. Let's say that I create a new file. Let's touch the file A to say something. If I do git status now, you see that there is a new file A that Git doesn't know about. So let's say that I want to add that file A and then git commit add A. Now my status should be clean, but my git log should show me that now my PR has an extra commit compared to master, so I'm ready to push it to my remote. But before I do that, let me show you the output of Git branch. Git branch shows the following. Remember, Git is created an automatic connection between my local master branch and the origin master branch, so that if I do git pull, standing on the master branch, Git will know that what I really want to do is to fetch from the remote origin, the master branch, to fetch every information in the origin and then merge the master branch. So those are automatic actions that were set up when I cloned the repository. But notice that I don't have something like this associated to my PR branch. My PR branch has nothing here, right? There is no square brackets saying you're tracking a remote branch anywhere. So how do I do that? Okay, usually a common way to do it is when you push something to GitHub, so the command is of course git push, you can say -u, which is a way to express U stands for upstream, and upstream means this automatic connection between your local repository and your remote repository. So you can, when you push something, you can already tell Git to keep track of the branch I'm going to explain right now. So you could do git push, and at the same time while you push, set this up, and then you say origin in this case, because I want to set up my remote origin, and the branch in this case PR. So this will create a branch PR called PR on the remote origin that will be tracking automatically my PR branch locally. That way, next time I want to, for example, push or pull, I just do git push or git pull without having to explain origin PR, right? So by doing this -u, I create that automatic connection. So that's one way, and let me show you another way. Actually, this is probably the way, yeah, let's do it this way first. So by doing this, what I should expect is that if I now go to the repository online on GitHub, I should see that there is this new branch that has been pushed to the Grace investing, right? So that branch is already ready for me to create a pull request. So let's update this page here. As you can see now, the GitHub detected that there is a new branch, and I could immediately click here to create the pull request. I'm gonna do that, or I could come here to pull requests, and the same thing happens. I already see that there is a pull request here. I'm gonna click here, compare and pull request. I'm going to confirm that it's looking good. So yeah, from the branch PR, Now all of this is happening in my remote copy of my local repository. So I now here on GitHub have a branch that is called PR, and I'm proposing these changes, in this case the addition of the file A, to be merged into the master branch on that remote too. The reason why I can do this is because I have now my remote connection set up. I was able to push that branch, and at the same time I set that upstream, that connection automatically, and I'm going to show you that in a moment. So for now, let me just create that pull request. So this is a workflow that you are already familiar with. Here is my commit, what I did. And now locally, let me show you what the output of Git branch looks like now. So let me clear this up. Git branch minus V now shows that the branch PR now also has this bracket section that says that this branch PR is associated with this PR branch on the remote origin. And you remember now that my remote origin is the one that is pointing to US investing, right? So that also means that if I do git pull, I don't need to specify origin PR. So Git already knows that what I want to pull is from origin and the branch PR. Okay, so we have our connection here, and say that someone I propose that PR, and say Jackson on the other end of the world is investigating that PR, maybe adding some changes and so on and so forth. Say that I want to continue working on that PR. What should I do? Well, the first thing you need to do is to update your PR with changes that might have happened in two branches. One is my own branch. My own branch on the remote is now exposed to the maintainers, and the maintainers can push changes there. So how do I make sure that if they did add any change, how do I make sure that I incorporate them into my local repository before I continue working? Well, with the command git pull, which is what I had just done. So what that does is, as remember, is a git fetch, right? Git fetch will bring all the metadata from that remote. In this case, I could be more explicit, git fetch origin, right? So that will bring all the metadata from the remote origin into my local repo, but hasn't merged anything. Then I could be doing something like git merge origin PR, right? So this is the explicit way to do all that I achieved just by doing git pull. So git pull, now that things are set up, does all of that for me. It's equivalent to fetching origin and then merging origin PR in this case. So with that, I made sure that if there was any change pushed to the branch PR on the origin remote, now I have it locally here. But what happens if some change was included in the master branch? Because this is, it is maybe not the only pull request. So maybe someone else is, submitted another pull request, and that pull request got merged into master, and then that master branch has one more change different to the one that I have here. So, well, what I need to do to keep really in sync is to now also merge the master branch from the origin, right? So what you do is the same thing. You could do a git fetch origin if you wanted to be explicit, and then you do a git merge origin master, right? If there was any change in master branch on your remote origin, then that change could have been included in your PR. So the takeaway for today is, as we work, keep in mind that if we are working with a remote, generally there is two places that you have to keep synchronized. One is your own branch on your remote, and two is the master branch on the remote. Again, as maintainers continue to update the master branch, you need to make sure that those changes get included in your PR, because you don't want it to fall too far out of sync, because what happens then, you increase the chances of having merge conflicts. If your PR is never updated against master on the remote, what will happen very likely is that by the time you actually want to merge your PR, it's going to be too far behind the actual master on the remote. And then you have to deal with merge conflicts. It's easier to fix the merge conflicts as early as possible if there is any, and this is the way to keep out of sync. So you git pull to update your branch, and you git fetch and merge origin master to get the changes upstream. So in this case, I'm not gonna merge this branch because it is just a toy branch and I don't want it to be merged accidentally. So I'm just gonna come here, I'm gonna close that pull request. And locally, what I could do is just destroy that branch. So I could do, actually before I do that, let me see, okay, so this branch is hanging there. So I'm going to delete it from the remote, right? But that didn't delete it from my local repository. So now let me do a git fetch to see if there is any change. And there was a change. That change is the change that I just caused when I click delete branch. So notice the effect of git fetch here actually did show some output. What was the change? Well, now on the remote repository, one branch was deleted. And now that I did git fetch, now Git knows about that deletion. And now locally, what I'm going to do is I'm going to git checkout master. And now that I'm standing on master, I can destroy git branch minus D PR. So with that, I deleted the branch PR and I'm done. So okay, I have 1 more minute here. I'm sure that this idea probably of keeping 2 branches in sync might be a little difficult to digest, so I would like to spend that last minute answering any question that we might have or hear any comment or extensions of what I've said.
Seems to be pretty clear what you
Clear?
just described.
Or maybe totally unclear. So once again, it is very, very, very common that the problems associated with Git comes from not keeping your local branches synchronized with these 2 places. The branch associated to your local one, but on your remote, the PR, and the master branch on the remote. Remember to sync both of them all the time. Doing this manually is tedious and I just don't do it. Instead, I do it through tools like the use this package or the GH command line application. I encourage you to search for whatever tool that you like and that abstracts all these, connections that you need to kind of remember to keep track of. In my case, generally what I do is I run a command, it's called rsync. And that will pull, depending on the branch that I am, it will check, the associated branch on the remote and the master branch too. So every time I need to do any change, I just run rsync, which is a wrapper around the function from use this, prsync, and that does all that magic for me. So if all of this sounded like too much work, it is, I agree, and I just don't do it. I use tools that abstract all of that and do it for me. Okay, so with that, I hope to have you inspired to find a workflow that does things for you and you don't spend time thinking things that use your brain in a useless way. But here we are. So thanks a lot for hanging in here, and that was it for today. Look forward to working with you on Git.
Thanks, bye.
Ciao, ciao. Thank you.